You think there's not a lot?
Closed captioning of this program is brought to you in part by Corner Gas Season 3 on DVD. Available now.
This is CTV Newsnet.
A major flare erupted on the sun overnight. That's both good news and bad. The good news is the flare will offer up a spectacular light show similar to the Northern Lights. Stargazers in Canada and the northern United States will be able to see this thing as early as tonight. The bad news is these solar flares send out clouds of charged particles. They can damage communication systems and power grids. Satellite operators and power grid managers have been advised to keep their eye on this storm over the next few days. Joining us now is Dr. Robert Rutledge. He's a physics professor at McGill University, and I'm really hoping he can tell us what a solar flare is. Can you do that, sir?
Hi, Dan. Certainly, yes. A solar flare takes place when a ball of magnetic energy bursts through the surface of the sun. It spits out an awful lot of plasma and magnetic field, and it's accompanied by a coronal mass ejection. In this case, a coronal mass ejection which is directed in our direction, towards Earth, at a velocity of about 1,000 kilometers a second.
Will it actually reach us?
It actually has reached us and is reaching us as we speak now.
So what kind of an impact does that have on anything?
Well, it produces, it carries with it a lot of protons and electrons which reach our upper magnetosphere, and they find their way down to the atmosphere of the Earth, and it produces quite an auroral show, which we should see tonight all the way far south as Boston and as far west as Victoria.
I've heard it compared to the Northern Lights. Is that accurate?
That's exactly correct. It produces the Northern Lights. Normally we have a sort of steady stream of particles, but with an enormous flare like the one that happened just 2 days ago, it should produce quite a show, and it should be visible over much of North America.
Well, that's the upside, the fun side. What about the downside of these things? They can disrupt electricity, I understand?
Absolutely. There are actually very serious implications. It's possible for enormous currents to take place in the atmosphere, which could then short out power stations. And some of your viewers might remember that happening in 1989 here at Hydro-Quebec. Put 6 million Canadians in the dark for quite some time. It also is a threat for satellites. If you bombard any electric equipment with protons and electrons traveling at 1,000 kilometers a second, it could affect the computer systems, and it could take some of them out.
Really?
Yeah.
So what about, we just the average Joes living at home? Should we be concerned with this? Is there something we should do about this to protect ourselves in our homes?
Well, no, there's no need to protect ourselves in our homes. The Earth's magnetosphere and the atmosphere does a pretty good job at making sure nothing really gets to ground level. But you might be aware of some power outage. It could take place anywhere in Canada and North America. So it's a good night to lay in extra candles and some blankets.
How long does this thing last?
Well, the brunt of it is hitting us now, and it should go on for another couple of hours, and it will dissipate over the next couple of days and pretty much be gone by Friday.
Do we know what causes these things in the first place? Like, why does these blasts of energy come out of the sun?
Well, we do know that these blasts of energies are related to the sun's magnetic field, and it seems that the sun has a magnetic field which is tied to its core, and as the sun rotates, it can wind this magnetic field up, and if it winds it very tightly, it produces a big, dense ball of magnetic energy, and that ball will rise to the surface, burst through the surface, and that's what gives us the solar flare and the coronal mass ejection.
Robert Rutledge, thank you very much, sir.
Well, thanks very much, Dan.
Liberal